Okay, the next four problems, 21 through 24, I don't recognize any of those numbers. For example, if you, let me see now, if you look at this, I don't recognize 0.28 or 2.5 or tangent, etc. So these have to be done approximately, of course, using your calculator. And the first thing that you have to decide, how do you want to write your angle? If you want to write your angle in radians, then make sure that your mode is on radian, and mine is right now. If you want to write your answer in degrees, make sure this is set to degrees. Notice that these other problems that I did, the first four that I did in terms of radians, okay? So why don't we stick to that? And in the absence of any other instruction, you know, it's up to you to what to do. But I'm going to use radians. Okay, so there we are. Now, theta theta is equal to cos inverse of 0.28. But one thing is for sure, whatever angle uh, that that the calculus spits out is going to be between 0 and pi. Okay, 0 and pi. Okay, so let's go ahead and plug it in. Let me quit that. All right. So we have second function, cos inverse of 0.28, and this is going to be an angle between 0 and pi. I guarantee you it's going to be an angle which is less than pi is 3.14. Okay, so it's going to be less than, so it's going to be 1.287. Okay, so here's 1.287. So one answer we get right away is 1.287. I don't have to write radian here, but it is. In the absence of not, when you don't write anything, means it's treated as radian. So here's the situation. What happened is that you were told that the cosine is 0.28. Now 0.28, let's say it's somewhere here, okay? 0.28. This is the cosine axis. So the angle that you just got, actually, the angle that you got is this angle you got, 1.287 radian. But there's another one in one period means 0 to 2 pi, which is right there. There's another one. So just look like that. Okay. So the other angle, so one is of course 1.287 approximately. The other one is 2 pi minus 1.287. Okay. Now, if I want to get this thing in terms of numbers, without the 2 pi. So let me go ahead. 2 pi minus 1.287. So it's going to be 2 pi, second function, here's a pi, minus 1.287, 1.287, and enter. This is the other 4.996. So let me write 4.996. 4.996, and let's double check that. If I take the cosine of 4.996, I better get 0.28. So cosine, this is just to check so that we make sure there was no algebraic mistake. 4.996. I'm just rounding off the third digit. This better give me 0.28. It's close enough, 0.28. Okay, so here's what happened. We found our two angles, 1.287 and theta equal to 4.996. Now remember, the first four problems that I did for you, they were like pi over 3 and 5 pi over 3 or something like that, okay? But not here. So all solutions is going to be taking these 1.287 plus 2 pi k. Remember, 2 pi k means 2 times 3.1415, etc. times k. So it's just a number, okay? and theta equal to 4.996 plus 2 pi k, where k is equal to 0, plus or minus 1, plus or minus 2, etc. And if it says give me 6, then just select three values of k, for example, 0, plus 1, and minus 1, and you get 6 values of theta. Okay, so let's go ahead and do the next one, which is 22. Number 22. Number 22 is tan theta equal to 2.5. I don't recognize which angle has 2.5 as a tan, so I have to use my calculator, namely theta equal to tan inverse of 2.5. Now remember, the calculator spits out an angle for tan inverse, an angle that's between minus pi over 2 and pi over 2. It just gives you one value. Then you have to go and find out what the other value is, and then keep adding multiples of pi to it. Okay, so let's see. First of all, let's use our calculator. Calculator, where is this thing? Second function, tan inverse, 2.5, not 25, 2.5. And the angle that's going to come out is correct, but that's going to be between minus pi over 2 and pi over 2. So it's going to be something between pi over 2 is about 1.57, etc., and minus 1.57. Okay, 1.190. Okay, so this is what I got. So we have theta equal to 1. What was that? 1.190. 1.190. Okay, now we also know that if you let's see, if you, how do I, different ways of okay, so actually this angle that comes out is between minus pi over 2 and pi over 2, and that confirms it. Okay, and if you look at the graph of the tan inverse, let me draw the graph of tan inverse for you to convince you that actually we don't have to look for anything else, because the graph of tan inverse looks graph of tan looks like that. It's a good way to look and go and check your stuff that we did a month ago. So there is your theta, and there is the tan function. And what we were told is 2.5. 2.5 is this height, this kind of a height, okay? 2.5, just look, 2.5. Notice that the angle that we got is right there, right there. So 1.9, I think it was 9.19190. I'm sorry. This was a mistake. This was 190. Okay, 1.190. So here's the period of function. Is there another angle with the height being 2.5? The answer is no. This is it. This is it. This is the only solution within one period of the function. Okay, this is one period of the function. There's nothing else, and therefore, if you want all solutions, just take whatever you got, 1.190, add to it multiples of the period. The period for the tan function is pi. Go back to your notes from a month ago, times k, where k is equal to 0, plus or minus 1, plus or minus 2, etc. And if you want 6 solutions, only just select 3 values of k, stick it in there, and you can see the answer in the back of the book. Actually, you may not see because your values of k may be different from their values of k. All right, let's do the next one. 23. Number 23. Again, it has to be done approximately because we don't recognize the angle. Tan of theta equal to minus 10. The first thing that we're going to do, we're going to say theta is equal to tan inverse of minus 10. And the calculus is going to spit out an angle between minus pi over 2 and pi over 2. Okay, so let's go ahead and stick it in there. So second function, tan inverse. Where is that? Tan inverse of negative 10, negative 10. I'm going to close the parentheses. Okay. And you're going to get minus 1.471, minus 1.471. So let's go ahead here. This is equal to minus 1.471. Now let's see what happened. The graph of tangent, the graph of tangent, we just did it. It looks like this. This was the graph of tangent. But this was pi over 2, and this was minus pi over 2. And of course, this is 0. We know that. So we were given a value of minus 10. Minus 10 is somewhere down here. Minus 10, minus 10, okay? So the answer that we got is actually right here. This is the answer that we got, right there, right there. Negative 1.471. And notice that in this one period, which is from minus pi over 2 to pi over 2, there is no way you have another height of minus 10. This minus 10 is supposed to be right up there. Minus 10. Okay, so this is it. Theta equal to minus 1.471. The only solution within one period. Of course, the one period that the calculus spits out, minus pi over 2 to pi over 2, because there are other solutions, but in other uh, pieces of the tangent function. And if you want all solutions, you have theta equal to whatever you got, this number, minus 1.471, plus multiples of the period, where k is equal to 0, plus or minus 1, plus or minus 2, etc. And if you want only 6 solutions, just use the value of k 6 times, okay? The last one from this category is sine of theta equal to minus 0.9. And that's number 24. These problems, as you can see, they take some time, and you always should go back and check your answers with what I'm doing here. Hopefully, I haven't made too many mistakes. I don't think I have, but anyway, or the answer in the back of the book. Okay. Don't be overconfident on your answers, thinking that it's right. Well, if you really want to know, look at my solution. Look at the book solution. 24. Sometimes we do things that we think is right, but it's wrong. We never check it, and therefore we won't find out what mistakes are. So sine of theta equal to minus 0.9. Okay, so theta equal to sine inverse of minus 0.9, and the answer that the calculator will spit out is going to be between minus pi over 2 and pi over 2, guaranteed. I'm sorry for minus pi over 2 and pi over 2. That's correct. So let's go ahead and plug it in. So second function, sine inverse. What was that? Negative 0.9. Negative 0.9. And you close the parentheses. And minus 1.112. I'm rounding it to third digit. So minus 1.112. Just keep that in mind. I can't remember. Hang in there. That's not what I meant. minus 1.120. That's what I meant. Minus 1.20. If you round this thing to the third digit, it's going to be minus 1.120. Minus 1.120. So theta is equal to minus 1.120. Now, uh, let's look at the graph of the sine inverse. I can do that actually in the trick for sine and cosine. I can use trig circles, okay, but or the graph of the sine function. But for tangent, it may be better if you use the graph of tangent function instead of the trig circle. But here's the situation. So you got minus 0.9 right over here, minus minus 0.9, and the angle that you got is this. This is the angle that you got, minus 1.120. But remember, the period of sine function, the period of sine function is 0 to 2 pi. So there's another angle right up here, right? Oops, not that one. Not that one. Just a second. Let me clean this up. There's another function. There's another angle right up here. This angle, which you can either do it like this, or you can go in the other direction and give a positive value. So there's another value, which is, when you think about this thing, this is going to be pi minus. So let me actually let me do it like that. So it's going to be see, this is minus 1.120, okay? So if you go all the way down here, it's going to be minus pi. So it's going to be minus pi and backtrack plus 1.120. So this is, let's see now, let's plug this thing, minus 3.1415 plus 1.120. So plus 1.120. So theta equal to, let me do this thing with my calculator, minus pi, negative pi, second function pi, right there, plus 1.120. And this is minus 2.021, minus 2.021. So minus 2.021. That is, look, that is this angle. This angle, okay? So let me write down my angles, the two solutions that I got, minus 1.120. The other one is minus 2.021. And these are two solutions within the period 0 to 2 pi. Actually, this is not 0 to 2 pi. You can think about it. Let me write it like here. Two solutions within the period minus 2 pi and 0. Okay, because they're both negative, right? So, okay, all solutions, just add multiples of the period here, minus 1.120 plus 2 pi k, and theta equal to minus 2.021 plus 2 pi k, k equal to 0 plus or minus 1 plus or minus 2, etc. Now, at the risk of confusing you, let me do this problem a different way, okay? So let me keep this thing. Okay, so let me see now. All right. I'm going to erase whatever I don't want, okay? So let me keep that. Anything down here I'm going to erase. There's nothing wrong with what I did, but I want to show you that some people may do it a different way. Okay, so let me erase all of these. It's better if I actually drew the trick circle. Okay. So do we have anything down here? Just a second. Yeah, let me get rid of these two. Now, if you're overwhelmed, that's okay. Just move on to the next problem, next video segment. But if you are still with me, let me show you how else could I have done this problem. Okay, so let me put this thing back on. There is my, this was the trick circle, right? Minus 0.9, so I got this. Let me erase these things right here. Now, the angle that calculator spit out is this. That is correct. But you can also get that angle by thinking about it like that. Okay? Except that it's going to be theta is going to be 2 pi, and then you subtract that. That's one of them. And the other one is going to be like this. You go here, and then you stop there. So theta is equal to 2 pi. Let me see now, or let me write it like this. It's easier if I wrote it like that. Pi plus 1.120. Okay, so the two angles that are these are, I can actually figure out what these things are, but let me do that. Let me do that here. 2 pi minus 1.120. So 2 to second function pi, okay, minus 1.120, 5.163. So this thing is 5.163. Let me find the other one. This guy. So second function pi plus 1.120, and this is 4.261. 4.261. So this one 4.261. So I found two angles. One of them is 4.261. The other one is theta equal to 5.163. These are two angles within the period 0 to 2 pi. Just look at it. They're both positive and they're both less than 2 pi. So all solutions is going to be 4.261 plus 2 pi k, and theta equal to 5.163. There's a 1 here. Plus 2 pi k, k equal to 0, plus or minus 1, plus or minus 2, etc. So these are all solutions, and they look different from what I had before. But in fact, if you use the values of all the values of k, there's infinite number of them. For the first set of solutions that I got, and I erased it, and this one, you'll see that these are going to appear somewhere in that list. Okay. As I said, if you're overwhelmed, don't worry about it. Just do it one way correctly. That's good enough. I'm going to stop this, and the rest of these are going to go in a third video segment.